Yes, friend. Now, in last video, I told you coefficient of self-inductance and phenomena of self-induction, and I told you L is called here uh, coefficient of self-induction. So now we will come here to the point: how does the inductance L depend on geometrical shape and size of coil or inductor? दोनों का यल होता है. सपोज इन फिगर वी टेक हियर प्लेन सर्कुलर कोयल. लेट इन फिगर वी हैव ए प्लेन सर्कुलर कोयल having capital N turns of a conducting wire of insulated conducting insulated means they are insulated so that they should not touch each other. Insulated from each other, having n turns. These turns are insulated each other. The turns are wound very closely. Actually, so that we can take a radius, है ना? So now, if capital I be the current passing through the coil, then magnetic field at center of coil is given by B equal to mu 0 and I upon 2R, where R is the radius of coil, where R is the radius of coil. Now this formula is true for center only. We have tried this formula for center of the loop. But now, if R is small, then magnetic field at every point inside the coil may be supposed to have same magnitude and this field will be perpendicular. अब ये लूप अगर है तो फील्ड नॉर्मल अंदर की ओर लाइक दिस. This formula is meant for center, but we have taken approximation that if R is small, and field is normal. Since field is normal to the plane of loop also, since B is normal to plane of loop also, so magnetic flux linkage of coil N phi is equal to N phi on the BA. Phi is BA. Flux magnetic flux of BA है. Magnetic flux is only B into A. और it is N into B. अभी लिखा हमने mu 0 N I upon 2R into A. And here A is the area of plane loop, that is pi R square. So you can write N phi equal to mu 0 N square pi R upon 2 into I. This is magnetic flux linkage. Or comparing this equation. Comparing this equation with N phi equal to Li, we get L is equal to mu 0 N square pi R upon 2. R is taken is small here, so that is going to be constant. If the loop is bound around, if loop is bound around a magnetic material, then material like soaked iron core, then L will be mu 0 mu R N square pi R upon 2. What is mu R called? Mu R, you know, is called relative magnetic permeability. I told you this while teaching some term in Mandarin. Mu R for iron is nearly 8,000 or 800 or 1,000. So it is, we can increase inductance L by not increasing N, it is equal to N square by increasing the permeability of material. But since mu 0, the mu 0 has its value is 4 pi 10 to the power minus 7. So value of L obtained of certain millihenry only, not large enough. It is not of Henry order. Theoretically we can give somewhere the inductance is 0.1 Henry. But generally inductance of plain coil or any solenoid is of 10 millihenry. Now, so L inductance of long solenoid. L means inductance. No, unit of inductance I told Henry. of long straight solenoid. Straight solenoid. Generally, we have in practice in use long solenoid. Somewhere we can use plain rubber coil. Somewhere we use toroidal solenoid also. So suppose here it is a long solenoid having n turns of insulated, that wire will remain insulated from the material used to prepare this core. This is long solenoid of length L, area A and capital N turns. So if current flows this way, there will be magnetic field pointing from left to right. Okay, a length. Left to right is the magnetic field. And that I am writing directly magnetic field of the solenoid B equal to mu 0 n I upon L. Magnetic field near the center. At times it is half, but we can assume this field constant, assuming field same. Assuming the magnetic field B same everywhere inside the solenoid. The magnetic flux linkage of coil, of solenoid, sorry. N phi equal to N phi B. B this mu 0 N I upon L or into area A. By phi equal to BA. Since phi equal to BA and B is this area is that. Or you can write here N phi equal to mu 0 N square A upon L into I. Comparing this equation with N phi equal to Li, we get L is more than the length, L is the inductance, we get L is equal to mu 0 N square A upon L. If the core is filled with magnetic material, if core has magnetic material, then L equal to mu 0 mu r N square A upon L. Some people write this expression in terms of number of turns per length. So, if small n is number of turns per unit length, then n equal to n upon L or n equal to nl, and then n equal to mu 0 mu r n square L square A upon L. This square gets cancelled, we get L equal to mu 0 mu r n square A into L. Here A into L. This area and length give volume of the solenoid. So this expression is also important for learning point of view. So this is the expression for coefficient of self-inductance. Once in board exam it was directly asked, okay, write the formula for inductance of air-cooled solenoid. Air-cooled solenoid. यानी कि empty space. So directly you require to write the formula there. So dear students, please learn these are simple things, fundamental things of physics. Okay, so I will take it now. In next video I will take mutual inductance.